welcome back. I want to talk about another vulnerability that we mentioned in the theory video, and that is cross-site scripting. If you remember, this is a vulnerability where we execute code due to poor user input filtering. In this attack, it is not the server that is getting targeted, but the users that visit that website. There are three main types of XSS attack. There is reflected XSS, stored XSS, and DOM-based XSS. And in this course, we will be covering first two, which are reflected and stored XSS. But before we do that, let's quickly remind ourselves of scenario as to how this attack looks like. So the attacker finds an XSS vulnerability, they inject JavaScript code that they want the target to execute inside of their browsers, and then anyone who visits that web page will execute the JavaScript code that you injected. This is an example of stored XSS, where the victim doesn't have to click on any links. All they need to do is to visit the same page on their own, and they will execute that script that you injected. So how does this work? Well, this is possible only in case the script that you injected is getting stored on the server. This would most likely be if there is, for example, a page where you need to type in some type of a comment, and then that comment will show on that page. If that comment input is vulnerable, then you most likely will have a stored XSS, because anyone loading that page after that will load your comment as well, and if your comment was a JavaScript code, they will execute that code. So what does this mean? Well, this means once you inject it, it will stay on the server, and server will host that page with malicious JavaScript code to anyone trying to visit it. On the other hand, reflected XSS is a little bit different. It won't work on anyone that visits the page, it will only work if you send a link with malicious code to someone. In this scenario, the server doesn't store our injected code on their side, so it won't be hosting the page with our code. However, the code injection vulnerability could still exist. If we find it, then we would craft our JavaScript code that we want victims to execute, and we would send those links to anyone that we want. Once they click on the link and open the website page, our JavaScript code will also get executed. Now, these types of attacks are usually used for session stealing or by attackers to mine on targets' PCs and create web botnets. But our goal is to just find the bug itself, and we will demonstrate how cookie stealing works later. Let's get straight into it. Okay, so the thing that we need is our Metasploitable running. I got it already up, and we also need the DVWA page. Make sure that you have burps running with intercept turned off, and once you do all of that, you want to navigate to the XSS reflected right here, because this is the first example of XSS that we're going to cover in this video. Another thing that you want to do is you want to set the security level to be low for our first example. And let's give it a try to figure out whether this even has an XSS vulnerability. So what does this application do? Well, here it asks us to input our name. So I'll just go and type here Alexa inside of this input, just to see what happens. So if I click on submit, okay, so it prints out hello Alexa. What a welcoming application, right? And this right here is an example of how it should work. You type in your name, it will welcome you with hello and then your name. However, what happens once we try to inject JavaScript code? The most simple JavaScript code, and what we usually do first once hunting for XSS, is type this code. So let me go in terminal just so you can see it better. So this arrow to the left, then script, arrow to the right, alert, and inside of the brackets we put 1 between single quotes, or you can actually put anything you want, and you close the script tags. And this right here is a JavaScript code. It tells the page to alert us with number 1. And once again, you can specify anything between these quotes. So what does this mean? This means it will open that small pop-up window at the top of the page where it should print out 1. And these script tags right here are just a way for us to tell the web page, hey, anything that's inside of these script tags, you should read as JavaScript code and not HTML code. And this at the end is just the closed script tag, which is telling the web page, here is where JavaScript code ends. This alert is a JavaScript function that will alert whatever is inside of these brackets. So let's give it a try, and let's input this inside of our user input instead of a name. I will copy it, go to my page, and paste it right here. So script, alert, and closed script. I click on submit, and here it is. We have XSS vulnerability since it ran our code and it opened this small window. We can see it says 1, which is what we alerted. Well, this was pretty easy. Since this was on low settings, we can assume no user input was filtered, therefore we managed to execute this. And as easy as this looks like, there are many pages that are currently on internet that are vulnerable to this type of bug, even with this simple script. And as harmless as this looks, it can be used to do some serious damage on client side, depending on what exactly you send them as JavaScript code. Let me show you what I mean. What you would do after actually creating the XSS vulnerability and finding it, you would copy the code with the JavaScript code that you injected, and anyone that clicks on the link, so I will just simulate right here someone clicking on a link, they click on the link that you sent, they press enter, they will also execute that JavaScript code. As we can see right here, they will also get a pop-up window that says 1. And this is a reflected cross-site scripting attack. Anyone that opens this link will also execute this. They don't have to type the JavaScript code themselves. Now that we did this, let us also take a quick look at the source code of this page. So I will open view source, and here is the PHP code for this specific page. And they just paste our input right here. They don't perform any filtering whatsoever. Now that we covered the low security level, let's try to find XSS in a medium level security to see if it works. So I will close this, go to the DVWA security, and I will change from low to medium. Click on submit, and this will change everything to a medium. So let's go back to XSS reflected, and let's first type the name to see whether it gives the same output. And it does. It prints out hello and then the name. So now let's try the same script that we did with the low security. So open script tags, I will alert 1, and I will close script tags. Click on submit. It seems that they actually remove the script tags. We can only see right here hello alert 1, and it doesn't give us a pop-up window that says 1. This means there is some type of filtering performed onto this page, because we don't get that window and our code doesn't get executed. By the output of our application, we can assume that the filtering performs removing of script tags. And usually this is type of filtering that you will encounter. Why? Well, because script tags automatically mean to the web page that JavaScript code is coming. So some web pages perform filtering just by removing these script tags. But let's see whether they filtered it well enough. They seem to filtered script like this, but have they filtered script like this? What if I write it in capital letters? Will that also be filtered? Let's give it a try. If I type script and then alert, and I also close the script with capital letters, click on submit, and here it is. We got it to run once again. So all we had to do was write scripts in capital letters. They only filtered out lower letter case script. Let's make sure that that is the case by going and visiting the source code, and let's see what did they do. And here it is. Inside of the print statement, they used the string replace function onto the script tags and replaced it with empty space. And that is the reason why with the first example, we didn't get script printed out, we only got alert 1 printed out, since they removed our script tags. But we managed to bypass this with capital script letters. But what would happen if they, for example, also filtered the capital script letters? Well, then we could do something like this. We could type, and let me write it first in terminal just so you can see it better. We could write something like this, SCR, and then open another, left arrow, script, close right arrow, and then IPT, close another, right arrow, alert 1, and close script tags. And the reason why we are writing script tags like this is because our web page only filters the opening script tags. It only filters this. It doesn't filter closed script tags. So what did we do right here? Why would this work? Well, before I explain it, let me first give it a try onto the web page just to see if it would work. And it does indeed work. So what I essentially did right here is I split this script tag into two pieces. And what the web page does, it only filters out entire script tag. So what the web page would do is it would see this opening bracket, then script and closing bracket, it would remove it, but then we would still be left with a script tag. So if I go right here, and let's pretend that we're at the web page, we'll filter out the opening script tag, so let's remove this. And what do we get? Well, we get another opening script tag that won't be removed. And that is why this would work as well. Great. Now let us see the attack where we steal cookies from the person that visits our link. Those cookies could then be used to steal their session and possibly enter their online account on that website if the website session management is also poor. Right now, we will see only how to get that cookie with cross-site scripting. So to do this, we must first see where are we going to receive the cookie value. So they will execute the code and our code will extract the cookie, but where is it going to send it? For this, we're going to start a small Python HTTP server that we will send the cookie to. So how to do that? Well, we can go inside of our terminal and just type the command python-m and then simple HTTP server and then the port number where we want to host it. Let's say port number 8000. If I press enter, this will start the HTTP server on all interfaces on port 8000. Then the malicious JavaScript code that we want to inject is this right here. I will first write it in another terminal and then we're going to copy it inside of the page. So we must first start with capital script. Because we are on medium level, the regular script won't work. Then we can type document.write, open brackets, then type one single quote, open another left arrow, and image source equals, open double quotes, HTTP / and then the IP address of our Cal Linux machine, and then the port on which we are running that Python server, which in my case is 8000. Then we can add another slash and close single quote. After it, we add a plus and then document.cookie. After that, space and another plus, and after that comes single quote, space, double quote, close right arrow, another single quote, close bracket, dot and comma, and then the close script tags. Okay, I know what you're thinking. What even is this? And this can be a little bit challenging for someone who never encountered JavaScript before. However, this is just JavaScript syntax. It's just the programming language. And after a few times trying XSS, you will pretty much get used to it and it won't be that weird looking once you write it. Since I assume that for anyone that hasn't encountered this before, this looks pretty terrible. But what we're essentially doing right here is we're opening script tags in capital letters because of the filtering on our page, and then we're writing the document.cookie, which is the cookie session of the user visiting that page and running this code, and sending that to the IP address on port 8000, since that is where we're running our Python server. And here we should get printed out the cookie session ID once someone visits our link with this JavaScript code. And at the end, all we're doing is we're closing the script tags. So let's give it a try and run this in our user input. Copy it once again, go to our page and type it here. If I press enter or submit, well, nothing seems to happen right here, but if I go to my web server, here it is. Here is our target's cookie. Here is PHP session ID, and that is the cookie value. It even tells right here that we got the security on medium. And this is something that we might be able to use to steal their session. However, more about that later. For now, we saw how to find an XSS vulnerability in both low and medium security level. As I said, this can be one of the challenging parts of the course. However, if there is anything you don't quite fully get, feel free to post a question so we can clarify it even more and make it understandable. Great. In the next video, we're going to do this same vulnerability, just we're going to see how it would look like if it was a stored XSS. Remember, this what we covered is called reflected XSS, and the target will only execute the code if they open the link with our JavaScript code. In the next video, we'll see the vulnerability where the JavaScript code gets stored on the server itself.